So previously we have seen what happens when a vector v is rotated around another vector n by an angle theta, what becomes its new position. And we have derived what is known as the Rodrigues formula. Today in this video we are going to reorganize the terms in this formula and going to introduce the concept of rotation matrix, three-dimensional rotation matrix. So to do that, I shall start by copying this formula once again. So the formula was v prime, the new position of the vector v was equal to the component of v along the axis of rotation, which remains unchanged, unaltered during the rotation, plus the perpendicular component v minus v dot n times n. This is the component perpendicular to the axis of rotation, this times cos theta plus the other term n cross v sin theta. Now I am going to rewrite this same formula in slightly different manner. But before that, I would like to tell what is the goal of this reorganization. So the goal of the reorganization is to write v prime, or the new position of the rotated vector, as a product of a 3×3 matrix times the vector v, the initial position of the vector. And we are going to see whether we can do that, whether we can reorganize the terms in this formula to get v prime in this form. So let's try that. So v prime can be written as, this can be the first term, which is the component parallel to the axis of rotation, can be written as n times n transpose v, where n transpose v is equivalent to n dot v or v dot n if I write n and v as column vectors. And then with this I have 1, so this 1 comes from this first term, minus I have the same term here, the parallel component multiplied by cos theta. So I subtract cos theta here, plus I have v times cos theta. Now v times cos theta can be written as the identity matrix 3×3 times the scalar cos theta times the vector v, plus here I have n cross v times sin theta. So this I can write as sin theta times n cross v, which can be written as the skew symmetric form of n, which we have seen previously, times v. Note that this is a 3×3 matrix, this is a scalar, so this is a 3×3 matrix times v. Here again we have a 3×3 matrix, which is identity, times v, plus here we have n transpose. So I shall rewrite this as n transpose v. So then I have a 3×3 matrix times v times this scalar term plus everything else plus so this is again equal to 1 minus cos theta, this term, times n transpose. So I shall take v out as common plus cos theta times I 3 cross 3, this term, plus sin theta times n cross whole multiplied by vector v. So this is a 3 by 3 matrix, which we can write as the matrix R, R standing for rotation times V, where of course R is equal to 1 minus cos theta times n transpose plus cos theta times I 3 cross 3 plus sin theta times n cross, and this R is called the rotation R rotation matrix. In essence, the effect of rotating a vector v around an axis n by an angle theta is equivalent to multiplying the vector v with a 3-dimensional 3 by 3 matrix R, where R can be expressed by this formula.